Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Stephanie Glenn, your host. I'm the Editorial Director of Data Science Central. I'd like to start our event off today by thanking Databricks for sponsoring today's event. Databricks is a long-time supporter of the Data Science Central community, and we are honored to have them sponsoring our event today. Today's webinar is entitled From Pandas to Apache Spark, to be presented by Databricks. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have two presenters who I'll introduce in just a minute. There will be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speakers, Tony Liu and Tim Hunter, both with Databricks. Tony is a product manager, machine learning at Databricks, and his product area is programmatic and interactive platform for data scientists and engineers. Tony developed the ML fraud model at Turo, which reduced the rate of stolen cars by more than 50%. Tony has a BS in statistics and an MS in computational social science from Stanford. Tim Hunter is a senior software engineer, technical lead, and the co-creator of Koalas at Databricks. Thanks for being with us today, Tony and Tim. We're looking forward to your presentation. Presenting Koalas, a new open source project unveiled by Databricks that brings the simplicity of Pandas to the scalability powers of Apache Spark. Data science with Python has exploded in popularity over the past few years, and Pandas has emerged as the linchpin of the ecosystem. When data scientists get their hands on a data set, Pandas is often the most common exploration tool. It's the ultimate tool for data wrangling and analysis. In fact, Pandas read CSV is often the very first command students run in their data science journey. The problem? Pandas does not scale well to big data. It was designed for small data sets that a single machine could handle. On the other hand, Apache Spark has emerged as the de facto standard for big data workloads. Too many data scientists use Pandas for coursework and small data tasks. When they work with very large data sets, they either have to migrate their code to PySpark's close but distinct API or downsample their data so that it fits for Pandas. Now, with Koalas, data scientists get the best of both worlds and can make the transition from a single machine to a distributed environment without needing to learn a new framework. In today's Data Science Central webinar, the developers of Koalas will show you how Koalas removes the need to decide whether to use Pandas or PySpark for a given data set. For work that was initially written in Pandas for a single machine, Koalas allows data scientists to scale up their code on Spark by simply switching out Pandas for Koalas. Koalas unlocks big data for more data scientists in an organization, since they no longer need to learn PySpark to leverage Spark. Tony, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Awesome, Stephanie. Thank you very much for the introduction. So Tim and I are really excited to talk to all of you about Koalas, a relatively new open source project whose goal is to enable a seamless transition from Pandas to Apache Spark. So, as Stephanie mentioned, there are some logistics here. We won't be able to hear you during the webinar. There will be a recording available afterwards. The slides will also be available, as will the notebook that we'll be using in the demo. And please feel free to submit questions. We'll address them in the Q&A. So I'll probably skip the introductions a little bit, but Tim is the tech lead and software engineer at Databricks, and I'm a product manager at Databricks. So a bit about Databricks first. It was created by the founders of Apache Spark. And basically, its goal is to bring together data science, engineering, and data analytics as well. And a bit about what the unified analytics platform is. There are three distinct layers. At the core is the Databricks Cloud Service, which runs on Azure, Databricks, and AWS. The layer above is the Databricks Runtime, which includes products like Databricks Delta, which is a managed version of the open source project Delta Lakes, which brings ACID transactions to the data lake. A highly optimized version of Spark, as well as support for data science frameworks, ML, and deep learning frameworks as well. And the topmost layer is the workspace, which is the interface that data users use, interact with Databricks. It includes the notebooks, dashboards, jobs, as well as recently announced Managed ML Flow, which is a managed version of the ML Flow open source project, which does end-to-end tracking for machine learning. So, to kind of frame this discussion, to give a sense of why we wanted to build this, to create this project, I want to walk us through the typical journey of a data scientist. So, as students, you learn data science through MOOCs, textbooks, university courses, and when you're learning data science with Python, Pandas, as Stephanie mentioned earlier, is usually the very first library that you use. And even when you move on into the workforce, in most cases, the data sets that you're working with can fit on a single machine, and you're still able to use Pandas for this. The problem comes when you're working with big data sets, where the Pandas single node approach doesn't work anymore, and you have to work in many cases with Spark DataFrames. And a very common scenario we see, this might be familiar to many of you, is that data scientists will often sample code and run analyses on their local machine with Pandas and the rest of the Python data science ecosystem like NumPy, Matplotlib, before handing off the code to a software engineer who then has to rewrite everything to work on Spark. So with that, I want to talk a little bit about Pandas. Pandas was created more than 10 years ago, and in this time it's become the main tool for data manipulation and analysis. And it's deeply integrated into a pretty mature single-node Python data science ecosystem, including packages like NumPy, Matplotlib, scikit-learn. And it's very good at handling different situations, including basic statistical analysis, handling missing data, and in particular, it can handle different types of data very well, including time series, categorical variables, and strings. And Tim will showcase some of this in the demo later on. And on the other hand, Apache Spark has become the standard for large-scale data processing. And many organizations that have the need for processing big data choose Spark as a unified analytics engine because it brings together streaming, ETL, ML all under one platform. And as mentioned before, it was created at UC Berkeley by Databricks founders. And Spark also has a wide support for different APIs. As a PySpark API for Python, it also has support for Scala, R, and SQL. So to kind of get into a little bit of why the transition from Pandas to Spark is not so easy, we have a side-by-side comparison of the two frameworks. There are similarities across both, but you can see where they start to diverge. One key difference is that Pandas data frames are mutable, while Spark data frames are not. But even actions like adding column, renaming columns, or counting values can be quite different, and this mental overhead often prevents data scientists from adopting Spark. To dig into like a short example of just reading in the file, renaming some columns and creating a new column by multiplying two columns together, we have Pandas on the left and PySpark on the right. You can see how they really start to diverge. And this kind of prompted us to work on Koalas. So Koalas was announced at Spark Summit over a month ago, and it's a pure Python library, and it has two main goals. The first is to unify the two ecosystems, that is the single-node Python data science ecosystem and Spark under a familiar API, and it approaches Pandas first, making sure it's compliant with Pandas. The second goal is to enable the seamless transition between small and large data. So we avoid the scenario that I described earlier, where a data engineer has to rewrite data scientist code. And since its launch just over a month ago, it's been quickly gaining traction. There have been weekly releases, and there have been well over 100 patches merged since. And there have been more than 10 external developers outside of Databricks making significant contributions. And the daily download count has exceeded 2,500. I think there are close to 50,000 total downloads at this point. To contrast PySpark, we have Pandas and Koalas side by side here. And you can see it's very straightforward to migrate from one to the other. Literally, we're only changing importing a different library and replacing PD with KS in this scenario. But it is worth noting some of the key differences between Pandas and Koalas, some things to be aware of when you're using, when you're making this switch. By nature, Spark does lazy operations. What this means is that operations only take place when you're displaying or writing a DataFrame. Secondly, Spark does not have implicit ordering. It does not implicitly have ordering. So in the short term, what this means is that some methods that rely on ordering, like head, tail, or iLock in Pandas, might not perform the same just now. But we are working to actually mirror the behavior in Pandas with this. But this is just something to be aware of. And the last key difference is obviously the one that we're really excited about. Pandas works in memory, whereas Koalas allow you to scale to multiple machines. And now I'll hand it over to Tim to run through a demo.
Thank you, Tony. So let me show you what Koalas looks like in practice when you want to use it for doing data science. So I'm going to walk you through the journey of a typical journey that data scientists would go through when they would want to analyze some data sets and do a simple machine learning estimation task here. So I'm going to use for that the Databricks environment, which combines in a single place notebooks, as you will see later, and also some the data sources, and also clusters. So this is the part which will be the most relevant here. So I have launched a cluster with, and I guess if I also share my screen, this is going to be better. Okay, so I have launched a cluster which includes here the latest version of Apache Spark, and also that runs Python 3, so Python 3.5 more precisely, with a number of libraries already loaded. So this cluster includes the standard libraries like Pandas and Matplotlib, and I will attach to this cluster the Koalas library. So as you can see here, this cluster, which is running on the cloud, has 3 other machines to distribute the workload. And I'll be leveraging all the 3 machines, these 2 extra machines, to do all the work. So unlike Pandas, using Koalas, we'll be able to seamlessly spread the computation across these machines without having to think about how they're being managed or how they are being launched in the background. So in order to use this library, and this is something that you would do also on your local machine. All I have to do is install this library from PyPy. This is already installed in the. This is already published in repositories in PyPy or Conda if you are used to these tools. And I have installed this library on my cluster. So now let me switch to the notebook on which I'll be running a simple data science task. So since we're here in California, I thought we might as well talk about how the California Fire Department works on solving its emergencies. So I'm going to walk you through a simple task here where we're going to quickly analyze the fire department, the fire department calls for service, so here in San Francisco, and we'll see how we can predict the time it takes for a fire engine to come on the scene after they receive a call. So for doing that, we'll go through the typical steps of doing data science. So we'll first load the data, then we'll quickly look at the data, introspect it, do some basic cleaning, then we will do some featureization so that the data can be then transformed into a form that is more amenable for machine learning. And then I'll show you how you can quickly use an existing machine learning model to do these predictions. So as Tony was mentioning, if you want to use Koalas, this is an external library, and you need to import it just like you would import Pandas. So instead of doing an import Pandas as PD, like is typically recommended for in all the tutorials for Pandas, here I'm going to import all the Koalas data space as import Databricks with Koalas as KS. And then this is going to load all the functions that are going to do the translation between Python API to Spark. So by the way, I should mention that this is all using a Python notebook. Koalas is strictly about Python and strictly about how you can leverage your Python skills using Spark. So if I wanted to use this data set here, so I have this CSV file, and CSV file, this is something that Pandas has no problem loading. I can simply use the read CSV function from Pandas and then pass a few options to indicate whether that don't have headers and that I don't want to load all the data. I just want to read a subset of the columns. And if I do that, it's a fairly large CSV file, so it takes about a minute here to read on a single machine. So here, when I use Pandas, it just reads it in the memory of my main computer, and it doesn't use any parallelization capabilities. So now, if I want to use Koalas for doing that, this is the same command. So here, read CSV, I can pass the same options, which columns I want to use, and behind the scene, you can see here that it is going to run using Spark. It is going to trigger some Spark jobs in the background. So, and these jobs are going to be spread across the 3 other machines that I have running, that I have at my disposal. And you see here that this is already much faster than using directly Pandas. The reason for that is that Spark is able to read pieces of the CSV file on each of the different machines. And then each of the machines will process a small fraction, all in parallel, of the CSV file. And then we can do our usual analysis. We can quickly look at what it looks like. So now this data here is going to be a Koalas data frame that contains that represents all my data, and on that I can call most of the Pandas functions. So here, for example, I can just quickly introspect the head, and I'm going to display it. So this is what the data is going to look like. Each of the lines corresponds, each of the line of this data set corresponds to an incident in which the firefighters had to intervene. So you can see here you have the type of incident, the date, when it was received, when it arrived on scene, And after that, a lot of other information about the circumstances of this incident. So what we'll try to do, just as a reminder, we'll try to predict the difference between. So we'll try to predict the delay it takes based on other parameters. So the difference between the time here on scene and the time it was received. And you can see here, of course, that some data is missing in some other places here. So here, this is a nice view of our data. What really does it? How really is it represented? Because as usual in these situations, the Pandas or Spark, for that matter, can understand some of the formats. For example, they can see that incident number is going to be a number, but they may not necessarily realize that this received column is a date. This is not the case by default. So to get a more sense of of what this data looks like in more from a system perspective, we can use all the typical Pandas functions here against my Koalas data frame, so I can get the shape. So I see here it has 40 columns and it has about 5 million rows. And we can ask also Koalas what the types of the object is. And here you can see actually one of the differences between Spark and Pandas. When you call this dtypes method, which is a standard Pandas function, Koalas will return you exactly the representation that you would have from Pandas. So here you would see that some of the elements are going to be small 32-bit integers. Most of the other columns are going to be objects. So by objects, we don't really know what it is. Typically, this is strings, but then we'd have to do a bit more introspection to know that. And then here, it recognizes that there are some booleans. So we can ask Spark to have more to give us the information about what it thinks the data is. And you see here that this is the same data. This is the same data seen from the perspective of Spark. So we have all these columns here, and you see here that Spark has directly a notion of string, which is exposed here. So we have here a bit more information coming from Spark. So here you can see one of the differences already between Koalas and Pandas, in that Pandas will give you some high-level information about your data, about the type of your data, that then correspond to what PySpark exposes. But PySpark can be a bit richer in its understanding of the concepts of the data concept. So of course, this is a very system and programmatic view of the data. Let's look a bit at what it's looking like in terms of numbers, in terms of the data. So you can call the ubiquitous describe function against this data set, and it will give you statistics about mean, max, standard deviation. Of course, it doesn't necessarily make always some sense, because Pandas doesn't have any notion of what the zip code is, and it doesn't know that, of course, standard deviation doesn't make sense on a zip code. But in any case, what is important here is that even though this data is distributed across multiple machines and it could be very large, it could be terabytes of data. You can do a simple call like you would use for describing the data. And behind the scenes, Koalas will call all the appropriate functions in a distributed fashion to compute all these statistics. Which is why you see here that when you call these functions, it is running some Spark jobs. And which is why it just takes a few seconds to do that, even though we're talking to multiple machines and dealing with significant data sets. So of course, we could go much deeper into understanding of the data. Let's show quickly how the API works, and to show you that if you use the Pandas, you can quickly leverage these skills against to use them for a very large scale of data without having to think when the PySpark is running under the hood. So for example, let's look at missing data, which is a typical task here. And even if the standard even if Spark has a different way of, by default, if PySpark has a different way of dealing with missing data, we expose here the family API of Pandas so that you can, if you're used to working, for example, in a subset of the data, then you're confident that this code will work on the large data set. So now that let's move on a bit and let's consider how we can represent our data into a form that is more amenable for doing machine learning. So this is which is the typical step that people call featureization before they want to do machine learning. So in that case, we want to be able to predict the delay, and we're going to build we're going to manipulate the data to build our delay columns here. So first of all, let's drop all the data which is not available. And this is, as you can see here, I can use the familiar drop not available method here on my data frame, specifying a typical option that you would find in Pandas. So, and this is all working pretty fast. And actually here you can see when you look at the time it takes for doing that, you see here it takes 50 milliseconds. This is extremely fast. The reason of this operation being so fast is because Spark under the hood, and Koalas under the hood will not run immediately the operation. Koalas and Spark will simply wait for the user to perform an action that requires the effective calculation before doing anything. So that means you can chain a lot of operations, and Spark also will warn you if you do something that is illegal before you effectively need to touch the data. So as we saw before, this data here, so all our time here, date time, entry, received, unseen, and so on, they are all represented as strings. So we need to give them, we need to understand, we need to give them a better representation than strings. And this is why we're going to convert them to date times. So Pandas has a function called datetime. And of course, that means Koalas also has this function called datetime here that can take a column of data and that will represent it into the appropriate datetime format. And it will, just like the Pandas version, it is able to parse a very large number of different strings to do this conversion. So this code here, the code I'm presenting here for converting to datetime is valid Pandas code. It is also valid Koalas code. So you can go back and forth between the two without having to think about how Spark is representing dates internally, like you would have to do if you were to just use PySpark. And just to confirm that it is working after I'm calling datetime, I see here that all the time have been parsed into this representation, which is exactly what I would expect here. The time here is the datetime 64 time. Okay, so let's move on. Let's do it also for received. And also here, as Tony was mentioning, you see another feature of Koalas where you can seemingly overwrite the data inside your data frame, which is something that is not easy to do with Spark. Okay, so now I can compute my my delay, which is simply the subtraction of the unseen datetime and the data datetime. And this is all easy to do now that Spark or Koalas has given, well, now that we have a representation of our data in terms of dates. Okay, so does it work? Yes, so I see here all the delays in seconds. And so now we have our response variable, and we see here this has been inferred as an int, as a long int under the hood. Okay, so now we computed a delay, which is what we want to predict. And let's also, for simplicity, gather that this delay depends on the type of call, the priority that the operator assigned to it, and the unit that is going to respond, whether it's a fire truck, an ambulance, and so on. So this is going to be, so this is the data that we're going to manipulate, and that we're going to, for which we're going to predict the delay here. So you'll notice here that you can, so a couple of things to notice. You can use all the usual syntax of selecting different columns here to, this is typical Pandas syntax. This works on this works on Koalas, of course. And if I want to, and whenever I display something, you'll notice that this is when Spark activates, and this is when we need to actually perform some computations. Okay, so since we see that these variables, call types, unit type, they seem to be having not too many variables. They don't seem to have too many values. So let's see what we can do to simplify a bit, and let's see actually how many values we have. So clearly here we see that for the unit type, we only have about 10 different types of units. Even airport or even a detective can come in. So a lot of so a few different variables, and also here you can see that you can select pretty much any of the columns and then call the typical Pandas operation on series, like value counts, which is very convenient for doing that. And you can see here that this is running a Spark job again. And again, writing that, you can definitely write that in PySpark, but this is a few lines of code which are not necessarily easy to write and can be fairly error-prone. Okay, so now that we see that our unit types, our call types, and the priorities are all discrete variables with a few elements, let's figure out how we can represent them in a way that is amenable for doing machine learning. So one technique which is popular for doing that is called one-hot encoding, in which each of the values of the variable will be assigned a full new feature, and that will be only activated when this value is the one that is present. So for example, here in the case of call types, if I have 4 different call types, then I will have a different value. I will assign one different value for each of these for each of these features, and I will put the value 0 for all the other ones. So you can definitely do that in Spark. There are some techniques in the Spark machine learning library for doing that, but they're not necessarily very easy to use, especially when you want to deal with multiple of these variables at once. And so Pandas has a function called getDummies, which directly does that for all the variables that are included in the DataFrame. And Koalas, of course, include this so that you can run at scale all the featureization without having to care about all the details of how to distribute these computations. So what does it look like after you run this? So here you go. So you see here that my call type has been blown here into all these different all these different variables, and most of them have zeros, but they just have ones when they get activated. So since here the database environment is meant to deal with big data, you see here this warning here that indicates that it will only attempt to show you a subset of the columns to make sure that you are not trying to fetch too much data into the interface. Of course, nothing will prevent us from displaying everything and to add more more variables if we wanted to. Okay, so now that we have our data represented in a form that is suitable for doing machine learning, let's apply a machine learning model to it. So in order to do that, I have created in a separate notebook a machine learning model, and I have loaded this machine learning model inside MLflow. So as Tony was mentioning, MLflow is a technology for managing the whole life cycle of machine learning models. And I have run an experiment here, which contains one model that I've created here. And so here I can actually, if I wanted to, I can track down which notebook and which version I created, but this is not but more importantly, each of these models is assigned a unique identifier, and with this identifier, I can then reuse this model directly inside my notebook just by using this identifier. So here I have this identifier, and I can then inject it here by using Koalas function called load model. And this will load the model from MLflow and make this model available for doing some predictions against both Pandas DataFrame, which is what MLflow already does, but also Koalas DataFrame, and doing so using the same syntax. So you could just use MLflow if you wanted to, with directly its built-in Spark support. The difference is that here, Koalas will take care of all the details of exposing this model inside Spark, and you will not have to deal with the low-level Spark user-defined function API to do that. Koalas takes care of all these details for you. Okay, so now I have loaded my model into my notebook, and I can see here that I trained a scikit-learn linear regression model. And now I can simply apply this model using the predict function of this model. This is standard MLflow code, but the twist here is that I'm applying it against a Koalas DataFrame. And then when I get my prediction, behind the scene, as you can see, it is going to run Spark to make these computations, and it is going to return the predictions. And you can see here, again, it takes just a few seconds to process a large amount of data because we are spreading it across multiple machines and because we are making effective use of all the computing power of a cluster using Spark under the hood. Okay, so as a recap, what did we do here? So we started from a data set, which a CSV data set, for which we wanted to do some machine learning prediction. We read this data set using the built-in read CSV tool. Then we quickly introspected the content of the data set to get a sense of what it contained, all while doing so using standard functions like describe or is an A and is not a number and so on. Then we used Koalas machine learning features to build some features and to build some good representation of this data that is amenable to machine learning. And finally, we made some predictions using this data at scale using a machine learning model trained and loaded with MLflow here. Okay, so with that ado, let's move on to the presentation. Okay, so what is the status currently of this? What is the status of the project so far? So as Tony was mentioning, we released it about 2 months ago, and we are right now on a very active schedule of weekly releases with very active community involvement. If you look at the repository, you see really daily changes and the few functions of the Pandas API being added these days on a daily basis. So I would say that at this point, about 35% of the DataFrame API has been implemented, and about 40% of the series API from Pandas has been added. And as well, we also have as well here all the basic building blocks such as toDateTime, getDummies, and all these basic conversion tools that are ubiquitous in any Pandas flow, the working flow. And here, I really want to give credit to Hyojin Jinwokwon and Takuya Uchin, who have been the 2 main contributors on the Databricks side to this project, and who have been really leading the effort along with the community. So what should we expect soon? So I have to say that the involvement is very much community driven. So this is what we would like to do. This is what we have in plan for implementing, but this roadmap, of course, will depend a lot on what your needs are. So what you will expect in the next release are performance enhancements, especially caching, because as I was mentioning before, Spark is lazy in nature, and in order to fully leverage Spark, sometimes it is necessary to give some hints to Spark to tell it to cache and represent all the data in memory, and this can lead sometimes to to dramatic performance improvements. So this is going to be available in the next release. One big feature which I'm very excited about is the adjunctions of the plotting library of Pandas. So if you have used Pandas, you know that it has some built-in plotting utilities. And these utilities are very convenient because they are aware of the structure of the data frame, and they can very quickly give you some insight about data set. So here we're looking at actually the community is looking at how to add plotting to directly inside Koalas. And the reason why this is so exciting is that you do not think, typically in these situations, users or data scientists have to resort to subsampling or just looking at a limited subset of the data in order to do plotting. It's really hard to do plotting at scale. So with these tools, you will be able to have some quick visual inspection of the data without having to think about the scale of the data. So a couple of other elements that are coming in. One is better indexing support. So with that, if you have used Pandas extensively, you know that it has excellent capabilities for slicing and dicing the data. And Spark itself does not have a built-in notion of indexing. So we're working hard on replicating the useful subsets of indexing inside Koalas so that Pandas users can directly leverage their code that requires good indexing. And also, of course, a lot of functions are being added around data manipulation because this is pretty much people expect it pretty much as a given. We just released the string manipulation, and the dates manipulation API will be added shortly. So if you want to get started, what do you need to do? So here I showed you how to do it inside the Databricks environment. If you want to try it out on your laptop, Koalas is a pure Python library, and if you have Python 3 installed, for example, if you use Anaconda or Miniconda with your scientific distributions, then you can simply run pip install Koalas or conda install Koalas, and this will install the latest version of Koalas. One caveat, one point I want to note is that it will not install by default PySpark. So you also need to run pip install PySpark, and if you do not do so, you'll have an error message reminding you how to do that anyway. So if you want to have more information about more documentation for other environments, or if you want to have a better understanding of the performance or see all the updates, I recommend that you go to the GitHub webpage, for which there's a link, and you can get the link after that with the slides if you don't get it here. Otherwise, you can also try on Google or any of your favorite search engine. You can look Pandas Koalas DataFrame or Pandas Spark, and you will get the link there. So I want to really emphasize the fact that this is a community-driven project, and we're actively looking for suggestions or for requests. So if you have some requests for some missing APIs, or if you see a behavior that you would expect that you see in your Pandas code, but that does not seem to be right when you run Koalas, then we're very eager to hear about it. So please submit some requests on GitHub. And if you want to contribute, it is very easy because a lot of the functions that we're adding are simply wrapping an existing PySpark or Pandas API. So when you do that, you simply have to, if you know the behavior of the function, then it is a matter of carrying over the test and the documentation and simply wrapping the existing function. So this is what Tony and I wanted to cover. If you want to try it out, definitely, by all means, I encourage you to try it on your laptop. If you want to have an environment that also includes MLflow or built-in support for Spark at any scale, I would certainly recommend you to try out on Databricks. We also have a free version called Community Edition if you want to try it out there. And without further ado, I'll give back the microphone to Stephanie for a minute.
Thanks, Tony and Tim, for that excellent presentation. We'll get started with today's Q&A session. And I want to thank the audience for their participation. We've got a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. During this Q&A session, I'll leave up this screen with contact information for Tony and Tim if you'd like to contact them following today's webinar. So let's get started. I think we briefly touched on this, but can you tell us how we install Koalas? That's the first question.
Yeah, so as Tim mentioned, you can install it via the Conda distribution or on PyPy right now. But the key thing to be aware of is that you still have to separately install PySpark.
All righty. The next question, Koalas must be imported into Python running on a Spark cluster, correct? In other words, you can't launch Python on your desktop and expect to use Koalas.
So I think the question is, can you use your laptop and basically replace Koalas, replace Pandas with Koalas? And the answer is yes. So one of the kind of goals of this, one principle that we have is to actually make it very seamless, so that if you're working with small data, we'll return Pandas DataFrames, and if you're working with big data, then we'll return Koalas DataFrames.
Okay. Next question, can we use Koalas on-prem with Cloudera Spark as well?
Yeah, so I really want to emphasize that even if this project is sponsored by Databricks, this project is fully open source under the Apache 2.0 license. And you can definitely use it with any version of Spark that is compatible with the open source, the officially endorsed Apache Spark version. The only requirement that we put is that you use a recent version of Spark. So Spark 2.3 and above are recommended. The reason for this requirement is that Spark, starting from Spark 2.3, a lot of interfaces between Pandas and the low-level engine of Spark have been added, which adds a dramatic performance improvement to when you want to combine together Pandas and PySpark. So this is why we recommend using at least the version 2.3 and above of Spark. That being said, some other versions can work also on some subsets of the API. I'm aware that some of the APIs are working with Spark of Koalas, working with Spark 2.1 and Spark 2.2. But officially, with the Koalas project only supports Spark 2.3 and above.
All right, thank you. And so you mentioned it was open source, but what exactly is the license for Koalas?
The license is an Apache 2.0 license, so it's a very permissive license. And you know, the reason behind that is because we really want to make sure that it's very open to the entire community.
All righty. Next question is about speed. Does Koalas run as fast as PySpark?
Yeah, this is a great question. So what Koalas does really is translating the API of Pandas into calls into Spark and PySpark. So in that sense, if you are it is going to be as fast as using any code you would write against Spark DataFrame. It's simply, you can think of it as a very convenient way of using Spark, and for that reason you get the convenience of Pandas and the speed of Spark. So after that, of course, it depends a bit on how much Spark sometimes can understand and accelerate your queries, and this is the case for pretty much all the operations. One place where people also may may expect to see some difference sometimes is that that Pandas has been built on the top of NumPy, and NumPy is mostly well known for doing heavy and numerical processing operations, while Spark is mostly built on top of Spark DataFrame is built on top of a SQL engine, and SQL engines are really good for doing general data manipulation. So one difference that you might notice in some high performance numerical code is that Pandas, so you'll see that Koalas for that will actually use will delegate the operations of some numerical operations to Pandas under the hood in a distributed fashion. So you still get the benefit of using all the machines that you have at your disposal. But for all the operations that are more general data manipulation, you'll get the same speed of Spark, and typically you can expect the speed to be on par or above the speed of Pandas. Of course, this will depend a lot on exactly what you are doing and how you're configuring a cluster and which version of Spark you are running.
All right. The next question is about stability. Is Koalas production ready, and how stable is the API?
That's a great question. So right now, we just released version 0.60, and we would not recommend using it in production until 1.0 because we may still make some breaking changes. But with that being said, I think so that hopefully answers both the stability question and whether or not it's ready for production use.
All righty, thank you. And is Koala available outside Databricks platform?
Yeah, as Tim mentioned earlier on, it's available. It's definitely available outside Databricks platform. It's available, just generally available.
Yeah. So and yeah, I want to also furthermore add that the package has been published on the PyPy repository and also on Conda Forge. So if you're using any of these tools, either Conda or Pip, then you can directly use them, as I was mentioning, using Pip install or Conda install directly from pretty much anywhere where you want.
All right. A specific question here. What does the toPandas method do?
Yeah, that's a very good question. So sometimes when you have a data frame, it is not enough that a data frame conforms to the Pandas API, but sometimes the data frame has to be a Pandas data frame. And for example, this happens if you want to use the Seaborn or the Matplotlib packages for doing visualizations. So the toPandas method converts your data stored in Spark into an actual Pandas data frame. So it does a conversion from Spark to Pandas. So as I was mentioning, this should be only done in very specific cases where you need to do that. The reason for not doing it is that that your data might be very big and stored on a set of distributed machines. And when you call to Pandas, you are forcing all the data to be collected into one machine. And this may take, and your machine may not have enough memory for doing that. So typically, when you would want to do that, you would either subsample, or you would know for sure that the data is small enough to fit in the memory of your machine. But think of this method as if you want an escape hatch, if you really need to use Pandas for doing some manipulation, and using an API that strictly requires Pandas DataFrame.
All right, thanks for that. And I think we've got time for a couple more questions here. If Koalas is a pure Python, is Koalas a pure Python library? How does it execute differently than PySpark, which is more of an API on top of the native Spark? Does it use Dask for parallel processing in the Spark ecosystem?
Yeah, so this is a very good question. Actually, this is a number of questions here. So let me start with the first one about the nature of Koalas. So Koalas is a pure Python library that builds on top of PySpark, and also on top of the Spark on the Spark APIs in Python. So in that sense, everything you can do with Koalas, you could write the equivalent code in PySpark. It just happens to be much more tedious to do. The other part, so the second question, which was, what is the relationship between Koalas and Dask? So for this one, so Dask is an existing project, is another open source project that implements also a very wide subset of the Pandas API in a distributed fashion. So these projects have these two projects have the same goal, which is liberating the data scientists from the limits of a single computer. But the way Koalas and Dask achieve that is technically different. Dask focuses more on distributing. So Dask is mostly a pure Python and C++ project, and distributes the Pandas computations across multiple machines. So the backend engine, if you want, of Dask is going to be Pandas. And Koalas builds directly on top of Spark, as is at its engine for running calculations in a distributed fashion. So the technology under the hood is different, and each of them have pros and cons. Dask has a larger machine learning library, while Spark and the Koalas can leverage all the API from around Spark, which includes also a graph processing library, its own machine learning library, and so on. So it depends a bit after that on what you want to do with your data and how you see it integrated with the rest of your system. If you want to have a strictly a Pandas or Pandas compatible environment running Python, then you may want to consider Dask. If you want to integrate in your environment also some other systems such as streaming, SQL processing, other system of machine learning, and also if you want to have a very good support for input and output of the distributed format from the cloud, then Spark, I would say that Spark has and Koalas in that sense would be more appropriate.
Okay, well, Tony and Tim, thank you. Some great answers to some very good questions. For those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Tony, Tim, and the Databricks team, so they can follow up with you after today's webinar. I have just a few quick announcements. Please mark your calendars for June the 4th, 2019, for our next DSC webinar. How does Tableau help you ask the right questions? Also, today's taping will be available for on-demand viewing later today and can be found on the homepage of Data Science Central in the Webinar tab located at the top of the page. And past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Databricks for their sponsorship, as well as to our speakers today, Tony Liu and Tim Hunter, for their insight into today's topic. My name is Stephanie Glenn, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June the 4th, 2019. Have a great day.